So let's talk about this other method. So what I want to do here is show you sort of a nice bookkeeping method for the chain rule. And I typically find that most students tend to find this an easier way to think about and use the chain rule. So between this video and the last video, you'll have these two techniques, and it'll be up to you to use whichever one you think is better for you. I'll stick with using this method through the rest of the videos because, as I said, I think most students tend to gravitate towards this one, and I want to keep consistent with that. But, all right, so how should we think of this? We're going to draw what we call a dependency tree. Right. So what is this? Well, at the top level, we have F, or Z. I'll write F this time, but we could write Z, right? Because Z is F, right? Now F depends on two things, X and Y. But in turn, X depends on R and theta, as does Y. So now we have this dependency tree here, where these are the independent variables. Let's write that. Independent variables. And so that's this level. Okay? And then we have the dependent variables. Right? And that's this level. Okay? And then the function is always at the very top. Right? So, I mean, of course, you could have here sort of multiple layers of dependent variables if for some reason you changed variables and then changed variables again. But we're just going to stick with one layer here. So how can we use this thing here to get at the derivative? Well, remember what we had to do, or when we wrote out that formula for the chain rule, what happened is we always start with the function, and we want to end with the variable we're taking the derivative with respect to. So in this case, let's say we do, not EX, I want to write solution. Right. Let's say we want to do dz dr. Okay? That smear is getting a little bothersome to me. Let's redo that there. Solution. All right. So dz dr. So remember, we had to go through all the variables of R, or of Z, and get to R. So Z depends on X, and then we can do dx dr, and then plus dz dy, dy dr. Right? So we could find this out using the chain rule. Now what's a convenient way to remember this? So we start up here, remember Z equals F, and we find all the paths from Z down to R. So it's easiest to just kind of, well, we'll move away from labeling them. So we can start, let's say we want to get to this R here. So we can go from F to X, let's call that 1, and going from F to X, what that means is we take the derivative of F with respect to X, or Z with respect to X. So that matches up with this guy here. And then we can move from X to R, and we're finally at R. And just like before, that will mean take the derivative of X with respect to R. Right? But now we can also go to this R down here. So we can do derivative of Z with respect to Y. So here's the third one. And then we can go from y to r. So we can take dy dr. Right? So when we're using this dependency tree, what we're really doing is looking for all the paths that start at the function, z or f or whatever it happens to be called, that go all the way down to the variables we want the derivative with respect to. In this case, r. Right? All right, and then that'll allow us to, without writing out gradient of f and g and the partial of g and all that stuff, we can just start filling this in right away. So dz dx is going to be 2x minus 2y. Then dx dr is cosine theta, right? Plus, well, dz dy, so minus 2x plus 2y, and then sine theta for dy dr. And then you see, well, now we're back at where we were. And then now we can just plug in this x and y here and get the same thing as last time, which was, when we plug everything in, we got 2, the point was to not do this, 2r cosine theta minus 2r sine theta times cosine theta minus sine theta. I actually meant to just write here, without writing this step, 2r times cosine theta minus sine theta squared. Right? And then you can do the same thing to get dz d theta, and you'll find it works just like before. So this is kind of a convenient little shortcut, but I think it's important that you see the appropriate way to think about the chain rule first before you learn shortcuts for how to do it. Okay?